Welcome back, guys, for another episode here at Automation. Straight into it today. This one we have is 1995, the oil crisis in the US. These companies approached us and they want to replace their large V8 muscle car with a small 4-cylinder sports coupe. However, the company doesn't have enough money and they haven't built an engine since the 1950s, so they've approached us to make them more efficient. Here's something we haven't seen yet. This is a pushrod engine. Pushrod engines are typically what you would see in like a V8. An old V8s used to be pushrod. So what they have is the camshaft down in the bottom of the engine here. So they have a timing chain on the front of the engine, and then the pushrod, which is inside the crankcase down in the oil in the bottom. So then the lobes press on the push rods, which then get pushed up on top of the engine. They have these rocker arms, so as the pushrod gets pushed up, the rocker gets rocked over and then pushes on the valve. So once again, you got a weaker spot with a push rod, and you've got a lot more moving parts and a lot more force required to move these parts. So the more force required to do a job, the more horsepower that's pulled away from the engine to do these tasks that could be delivered to the wheels. So it's utilizing horsepower that could be used elsewhere. Other things that use horsepower but then are efficient is like a supercharger, because if you have a supercharger on the front of the engine, you use horsepower to turn that supercharger, but the horsepower produces more power than it needs to run it. So say it needs 100 horsepower to run it, but it might produce 200 horsepower. So you still end up gaining horsepower. But with push rods, you don't. They don't produce any more power, they just take power away from the engine. So we do have a cost requirement, so we can't go crazy on it. So potentially for a 4-cylinder engine, a cost-effective way would be going to an overhead cam. So this is a direct acting overhead cam, so the cams are pressing straight onto the followers and pressing the cams in. So we're looking at here that this is a cheaper option as if we go to anything else. So we're going to look at doing that, spending our money there. And the other thing, like I always like to do, is the fuel delivery system. Especially for a 4-cylinder, there's just no need to have carburetors. In the year's 1995, so we can just upgrade to fuel injection. So we've got our performance requirements. We still have an RPM limit and a loudness, so that the vehicle can't have it be too loud. An easy one to fix, we can go and we'll just raise the RPM at a very low RPM, and we need regular unleaded. So we still need to make this engine more environmentally friendly, so we need to utilize the fuel and air that we burn, so that we're not wasting any and coming out as carbon and soot and crap. And the loudness, so let's just have a quick look at the exhaust. What have they got? So we've got a short cast, so we can have a cast along, just a single pipe, which is not efficient because the gases don't flow in a nice efficient way. So we look at a race exhaust, and all these pipes are the same length, and they're all tuned so that when they join into one pipe, they've all traveled the same amount of distance. So you don't have gases from one cylinder pushing on another. They all work together and they all flow. But obviously having to get this crazy contraption here takes up a lot of room and costs a lot of money to make, and we're not going to gain from it. So a long header is a nice compromise. They're easy to make, but you still get nice smooth flowing gases. Or a tubular header, which is very common, so it brings them into two and then into one. Or the short cast header, or the cast header. So they are the exhaust options. We don't really need the extra power. There's not a high performance engine to begin with, so we'll just stick with that. We've got a baffle, so one way we can make this more efficient, to reduce the emissions, is to put a catalytic converter. So a catalytic converter has, what it does is it's got some special metals in there which get really hot, and they burn off some of the harmful gases that come out of the engine, and then they sort of neutralize the gases and burn off the bad parts so that it can flow out the exhaust. There is a lot more science to it, and I don't really know enough about it, but if there's someone out there that does know more about them, they happy to fill us in on what I've missed or what I've got wrong. But essentially they make the exhaust gases not as dangerous, well, not as dangerous, not as bad for the environment. And it also fixed our exhaust loudness problem. So we've still got to look at the emissions. How can we make this engine more or less emissions? So we can, where is it? We can look at the cam profile, I think. Not really going to do what we need. We can look at fuel mixture, obviously. Right, so looking at this engine, what we've done, or just done there, is I just adjusted the compression just down a bit more, and I just fiddled with it and added up the high flow 3-way catalytic converter, the top line converter. It was taking me a while just to figure it out, and I was just playing forth, going back and forth between everything just to find a happy medium. But there it is. Found a happy medium and got another successful engine. So this one, we've been asked by a British sports car company to help make an engine for their classic roadster. They haven't been having a lot of luck themselves, and they've come to us. There are some requirements, so we've got to use the DCOE carburetors. We cannot use a race intake. We have to have a certain performance of 45, reliability of 30. It can't be any louder than 60, and $1,800 total cost. So let's look at what they've got to start with. So the exhaust is not very efficient, and obviously we're going to have to change. We've got a particular type of carburetor that we have to use. It's an 1800, and it's got to stay in 1800. They have got, what is under here? Dirty old pushrod engine. We'll definitely look at changing that. But we can't. It has to stay. It has to stay. We can change the head material. Okay, so first of all, let's change the things we have to change. So that's that. So we're just going to make this engine more reliable and still keep it performing. So it's just valve float's just starting to occur. And the exhaust is restrictive. The exhaust is very restrictive. So before we get too far along, we can't use race exhaust. We've still got plenty of money available. Exhaust is tiny. So we only need to use the one baffled muffler. We're still fine. Let's look at that RPM. Drop the RPM, will make the engine more reliable. So, looking at the colours, they're still very green. So reliability there. It's getting more and more reliable. We can look at other things that will make the engine more reliable. Let's look at some of the materials. There we go. Done. So what I did there was change the head material. Aluminium is very soft. It is lightweight, but cast metal is very strong. And that was the final thing we needed to get that one going. Nice and easy. All done. Okay guys, on to the next one. We have got to build an engine for a small city-based car. So we've got some size requirements and some other requirements. Alright guys, I think that's going to wrap up the episode there. So, make sure that you subscribe so you don't miss out on future updates of this series. Always look for ways to support the channel down in the description below. And until next time guys, thanks.